these two parameters are very important to determine the transmission characteristics of the fiber with operating wavelength. Okay, so first of all, what are the losses or signal attenuation? We are going to discussing these topics. That is, what are the losses or signal attenuation? What is signal attenuation? It is the fiber loss. Okay, and what degree do the optical signals are getting distorted? We are going to discussing about this. So first of all, we are going to see about the attenuation. Okay, so what is signal attenuation? Signal attenuation means signal loss. Okay, or power loss in the fiber cable. Power loss in the fiber cable. So it is the most important characteristics of the cable. Okay, so signal distortion is causes due to the optical pulses. While when the pulses become broadening, as they travel along the fiber, what happens? Resulting there is a limitation in the information that we receive. The information is carrying along the fiber. So that's about the basic. That is signal degradation. Under signal degradation, the fiber is degraded by the two mechanisms. What are the two mechanisms? The two mechanisms are signal attenuation and another one is the dispersion. So first of all, we are going to see about what is attenuation. What is attenuation? It is the power loss in the fiber cable. Okay. So normally, the attenuation is the measure of decay of the signal strength, or it is the loss of the light power. Okay, the decay of the signal strength or loss of the light power. This occurs when light pulses are propagated through the fiber. Okay, so here how can you measure the signal attenuation? Normally it is expressed in the logarithmic unit of decibel. Okay, so it acts as the major role in determining the maximum transmission distance between the transmitter and receiver. Okay, so due to this attenuation, it reduces the signal system bandwidth, information transmission rate, efficiency, system capacity, etc. Okay, so normally it is expressed in logarithmic unit of decibel. That decibel is used for comparing the two power levels. Okay, so it in which the optical wavelength is the ratio of the output optical power from the fiber to the input optical power. Okay, it is given by this equation. See here the power loss of the fiber. So first starting the value of z equal to 0 and ending the value z equal to L. So what about the power? It is e power minus, that is alpha is the attenuation, alpha p into L into p of 0. Okay, so it is expressed in the logarithmic power. So how can you express this? Alpha dB per kilometer. So what is alpha dB? It's the total reduction in power level. Okay, so reduction power means attenuation in decibel. That is alpha dB. And next P naught is the output power, cable output power, and PI is the cable input power. So the total power loss is expressed as alpha dB is equal to 10 by L log P of 0 divided by P of L. Okay, so the relation between input and output power is PI by P naught is equal to 10 power inverse. If you take a inverse of that logarithm, you got 10 per dB by 10. Okay, so what are the basic attenuation mechanism? Coming under the basic attenuation mechanism, the basic attenuation mechanisms are absorption and scattering loss, and then the bending loss of the film. These are the types of the attenuation mechanism. So first of all, coming under the absorption, it is divided into three types. One is intrinsic absorption, extrinsic absorption, and another one is the absorption due to atomic effects. And then under intrinsic absorption, I want to discuss about the absorption due to infrared rays and UV rays. Next, extrinsic absorption, how much amount of the impurities and then washed molecules. We can discuss this. Then next, the attenuation is due to scattering, and next the attenuation is due to bending loss, etc. So the first two losses are intrinsically present in any fiber, and the last losses depends upon the environment. Okay, so the absorption and scattering is present in any fiber, but the bending loss is due to the depends upon the environment. Okay, environment the fiber is there. So first of all, we can see about the absorption. Okay, so what is the absorption? So it's also a loss mechanism, correct? It is due to the material composition or fabrication process, and there is a result of absorption. Okay, so the absorption of the light may be either intrinsic or extrinsic. Okay, is intrinsic absorption and other one is the extrinsic absorption. So what is intrinsic absorption? Okay, so it is caused by the intrinsic absorption is caused by the interaction with one or more major components of the glass. Okay, caused by the interaction of the glass molecules, that is components in the glass, that is it associated with the fiber material. For example, you can take pure silicon dioxide. Okay, so extrinsic absorption is caused by the impurities within the glass. Okay, within the glass. So the absorption losses is mainly related to the material composition and the fabrication process. Okay, so this absorption, so first of all we are seeing about the intrinsic absorption. In this intrinsic absorption, it is absolutely pure silicate glass. Okay, it has the little intrinsic absorption. Why it has the intrinsic absorption? Due to its basic material structure. Okay, and it is near the infrared region. So it is this results due to this silicate, that is pure silicate glass has little intrinsic absorption. Okay, glass material has the intrinsic absorption. So what happened? It results the electronic absorption in UV region and atomic vibration in IR region. Okay, so due to this factor, due to the pure silicate glass has little intrinsic absorption, so it results it results the electronic absorption and atomic vibration. So in intrinsic absorption, it is absolutely a pure state. Okay, it is a pure state, that is it has no density variation or impurities or material in inhomogeneities. Okay, the intrinsic absorption has a lower limit on absorption. Okay, lower limit on absorption. It results from the what are the results? That is electronic absorption band in UV region and atomic vibration band in the IR region. So first of all we can see the UV absorption, that is the electronic absorption. What is this electronic absorption? And it is associated with the band gaps. Okay, band gaps in the amorphous glass materials. Okay, so we are seeing the intrinsic absorption. So intrinsic absorptions occur in the pure silicate glass. So this results the fundamental UV absorption as well as the IR absorption. So in UV absorption also it happens in the glass molecules only, but when due to the electronic transition within the glass molecules. Okay, electronic transition within the glass molecules. Here this UV absorption, that is absorption. When will this absorption occurs? Means when a photon interacts with the electron in the valence band. Okay, what happened? You know, the valence band, there is an interaction. So when photon light, okay, when it interacts with the electrons in the valence band, what happened? It excited to the higher energy level. It moved to the higher energy level. Well, in higher energy level, it's a UV ray. So ultraviolet edge of absorption band. Okay, that's both the amorphous materials. So you can relate this using the Arbach rule. What is that rule? Means C into E power E by E naught. That C is the photon energy. Okay, it is inversely proportional to the wavelength. So UV absorption decays exponentially with the increasing wavelength. Okay, so UV absorption, when this absorption occurs means when a photon interacts with the electron in the valence band, it excites to the higher energy level. Okay, so because of this there is absorption of glass. Okay, in the UV region, that is that ultraviolet loss is small when compared with the other losses in the infrared region. So coming to the IR absorption, it is due to the molecular vibrations. Okay, vibration. So UV absorption is due to the electronic transition. Okay, it is due to the transition when the photon moves from the when it interact with the electron in the valence band, it moves to the higher energy level. So there is a transition is happening. So at that time there is a electronic absorption. Okay, it occurs in the glass material. So coming to the infrared absorption, when it occurs means it is due to the vibration. Okay, due to the molecular vibration. So when it happens, when it when there is interaction between the vibrating bond as well as the optical signal. Okay, there is the optical light signal. When there is a vibrating, when optical signal get vibrated, this the IR absorption will happen. Okay, result there is a when there is an interaction between the vibrating bond and the optical signal, what happens? There is presence of OH ions. Okay, so this is about the intrinsic absorption. So these are the characteristics of fiber attenuation. So here it is a absorption loss in UV region, and this is the absorption loss in the IR region. Okay, so see the absorption loss characteristics. So here the photon energy and here the loss. What about the loss here? It's increasing. Here also the loss is increasing. Okay. So next, this extrinsic absorption. So what is extrinsic absorption means? It is due to the impurities, okay, that occurs in pure state. Intrinsic absorption. This extrinsic absorption, this absorption is occurred due to impurities in the fiber material. So what are the impurities? There is the transition metal impurities as well as the OH ions. OH ions is the water ions. Okay. So intrinsic absorption occurs in the pure state. So here it occurs due to the transition metal impurities as well as the OH ions, that is the water ions. So what is this transition metal impurities? That is the iron, cobalt, chromium, nickel, copper. These are the metal impurities. Okay. So here the absorption losses occur because of the electronic transition between the energy level, which is associated with the incomplete filled inner subshell. Okay, so there is inner subshell, so it is incompletely filled of these ions. So because of if there is any change transition from one ion to another ion, this absorption loss will occur. Okay, can you understand? So when this impurity absorption loss occur means because of the electronic transition only. So electron transition occur between two energy levels. Okay, so when it occurs means if there is any incompletely filled inner subshell of these ions, or if there is any change transition from one ion to another ion. Okay, so when these states occur means there is the impurities, there is the transition metal impurities there. Okay, so due to this there is absorption will occur. And next, if you see the OH ion impurities, that's the water impurity. So it is another major extrinsic loss mechanism that is due to the absorption. Absorption is due to the water. Okay, when it is dissolved in the glass. So these hydroxyl ions are bounded in the glass structure. Okay, so this OH impurity or results from the oxyhydrogen flame when it used in the hydrolysis reaction. Okay, this type of absorption is reduced by reducing the water content in the fiber. So how can you reduce this absorption? Means you want to reduce the water content. Okay, when you reduce the water content, how can you reduce about 1 parts per billion? If you reduce this means you can reduce this type of absorption. That is OH ions impurities absorption. Okay, so it results the peak large absorption up to 1400, 950 and 725 nanometer. Okay, so these are the major extrinsic loss mechanism. So I said you this due to the introducing the glass fiber when fiber is cooling by means of the oxyhydrogen flame. Okay, so it is bonded in the glass structure. Okay, and see, so in evolution of optical fiber there are 3 windows, when it is at 800 nanometer, then 1000 to 300 nanometer, then 1500 nanometer. Okay, so in each level see the attenuation level. So in first level it is low, and in second window see it is somewhat higher, and again it is increasing. Okay, so you see this diagram. So these are the attenuation mechanism. Okay, so we have seen the absorption mechanism. So absorption mechanism, see what about the fiber? What about the fiber loss? So here some when signal is transmitting, there is a loss due to the absorption. Okay, so this figure shows the loss due to absorption. These are the intrinsically inside the fiber what happened. Extrinsic, you see that it may occurs in the connectors or splices or bending losses. Okay. So we have seen the 3 major windows. That is the first window at 850 nanometer. The attenuation is about 2 dB per kilometer. And second window is about 1300 nanometer. The attenuation is about 0.5 dB per kilometer. And then for third window, it is at 1550 nanometer and attenuation is about 0.3 dB per kilometer. Okay. attenuation level, it is decreasing, that is from 2 dB. The fiber attenuations are low. Okay, from 2 dB it is reduced to 0.3 dB per kilometer. Okay, and next is absorption due to material defects. So what are the three types? One is intrinsic absorption, extrinsic absorption, and third level is due to the absorption due to the material defects. Okay, so coming to this absorption due to material atomic defects, there is the atomic. What is the atomic defect? These are the imperfections. Okay, when there is the imperfections in the atomic structure of the fiber material. For example, what are the imperfections? If there is any molecules are missed, or if there is any high density clusters of atom groups, or if there is any oxygen defects in glass structure, then what happened? There will be some atomic defect. Okay, these are the imperfections in fiber. Okay, so if there is any imperfections, then there is an atomic defects in glass structure. Okay, so these absorption losses are negligible when compared with the intrinsic and extrinsic absorption. Okay, so it is very negligible effect when compared to other intrinsic and extrinsic absorption. Okay, so first of all we have studied about the attenuation. What do you mean by attenuation? It is signal loss in the fiber. Okay, or power loss in the fiber. It is classified into three types. One is absorption loss, scattering loss, and bending loss. So first of all, we have seen the absorption loss. So what is the absorption? So it is mainly it occurs when due to the material composition or in the fabrication process. Okay, it may be divided into extrinsic absorption, intrinsic absorption, and absorption by atomic defect. So coming to the intrinsic absorption, it is caused with interaction with one or more major components of the glass. Mainly it is occurred in the pure state. Extrinsic absorption is caused by impurities within the glass, that is, it is the impurities that occur due to the impure state. Okay, so intrinsic absorption, it results the electronic absorption as well as the IR absorption. Extrinsic absorption, it occurs due to the impurity level. Okay, due to the impurities in the fiber material. What are the impurities? Transition metal impurities as well as the water ions, that is the OH ions. Next we have seen the absorption by atomic defect. So it occurs due to the imperfections. Okay, it occurs due to the imperfections. And next loss is the scattering loss. Okay, next is the scattering loss. So what is scattering loss? Scattering also results in attenuation. Okay, it is the form of the radiation. It occurs due to the following factors. What are the factors? Means microscopic variation. Okay, some of the factors, that is, scattering losses occur due to the microscopic variations in material density, compositional fluctuations, then structural inhomogeneities, then structural defects occurs during fabrication. So these are some of the factors in which occurs due to scattering losses. Okay, because due to scattering losses. So here, if you see the scattering losses, so it will give rise to the refractive index variation. If there is any scattering loss in the glass fiber, if there is scattering loss, means it leads to the refractive index variation within the glass. Okay, so what happened? This index variation causes the scattering of light. If there is any variation in the refractive index, there is a scattering of light. So that scattering is known as the Rayleigh scattering. So here also the scattering losses is of two types. One is linear scattering loss as well as the non-linear scattering loss. Under linear scattering loss, it is divided into two types. One is Rayleigh scattering as well as the Mie scattering. Okay, Rayleigh scattering and Mie scattering. Non-linear scattering losses is divided into two types. One is stimulated Brillouin scattering, another one is the stimulated Raman scattering. Okay, so Rayleigh scattering, Rayleigh scattering comes under the linear scattering. Okay, so what is this linear scattering means? The optical power transfers linearly. Okay, from one propagation mode to another propagation mode. Okay, so linear scattering means the optical power is transferring linearly from one mode to other mode. So when this linear scattering loss, it occurs in the leaky mode. Okay, leaky mode or radiation mode. Can you understand? extend up to the infrared region. Okay, it starts from ultraviolet region and extend up to the infrared region. Okay, it is a fundamental loss mechanism, and when it arises means due to the microscopic fluctuations in the density. If there is any microscopic fluctuations in density, this Rayleigh scattering will occur. Okay, it leads to the random fluctuations in the refractive index. Okay, if there is any random fluctuations in the refractive index, this Rayleigh scattering will occur. Okay, so when this Rayleigh scattering, it is a arise means it arises from the if there is any fluctuations in density. What is density? The volume. Okay, so if there is any fluctuations in density, this Rayleigh scattering loss will occur. So this density fluctuations lead to fluctuations in the refractive index. Okay, fluctuations in the refractive index than the optical wavelength. So the light scattering in such a medium is known as light scattering, which occurs in the medium is known as the Rayleigh scattering. Okay, so Rayleigh scattering in the glass is same as that of the scatters light from the sun. So if you see the light is scattering from the sun, the mechanism is based on the Rayleigh scattering. Have you ever think why the daytime sky appears blue? Why? Because short wavelength. Okay, short wavelength is blue. So sunlight is scattered at the blue. Short wavelengths of blue color, blue sunlight. Okay, short wavelengths of blue sunlight is scattered and making the sky appear blue. And long wavelength or which color? Red color. So red sunlight is not scattered by the atmosphere. Only the atmosphere is scattering the short wavelength light. So short wavelength is which color? Blue color. Okay, so the scattered. It is scattering. See, here this is the scattering mechanism. So short wavelength, the blue sunlight is scattered and making the sky appear blue. Long wavelength is red color, but it is not scattering. See, there is no scattering mechanism for long wavelength, and it is not scattered by the atmosphere. So this is the reason why our sky is appear blue in color. Why the daytime sky appear blue in color? Because of the short wavelength, blue sunlight is scattered, making sky appear blue. Okay, making sky appear blue. See, the short wavelength and long wavelength is red color. Okay, the red color is not scattered, and this so this is the Rayleigh scattering. Okay, Rayleigh scattering. Here the sun is appear blue in color. Okay, so next we can see about the Mie scattering. Okay, Mie scattering. So before seeing Mie scattering, see the Rayleigh scattering. Here the intensity of the light is inversely proportional to the fourth power of its wavelength. Okay, the intensity of light is inversely proportional to the fourth power of the wavelength. Okay, so see here why we are saying the fourth power of Rayleigh scattering from air molecules, and this is the observer. Okay, so to the wavelength, fourth power of the wavelength, the scattering is almost in all directions. See, the scattering is almost in all directions and produces the attenuation that is proportional to the fourth power of the wavelength. Okay, so next is the Mie scattering. So what is Mie scattering means? See, linear scattering may also occur at inhomogeneity. Okay, so these results from the non-perfect structure. Okay, if you see the Rayleigh scattering, it is occurred mainly due to the density variation. Okay, so here it may caused by the fiber imperfection such as irregularity in core cladding interface or core cladding refractive index differences. Okay, and due to the diameter fluctuations, so this Mie scattering may occur. So it occurs due to the inhomogeneities in forward direction. Okay, so important created by such inhomogeneities in forward direction. Okay, so this occurs due to the inhomogeneities. So it arises from imperfections. Okay, so if there is any irregularities in refractive index, if there is any bubble surface, and it mainly caused due to the manufacturing fabrication process. Okay, so can control. So you want to reduce the Mie scattering. Okay, maybe how can you reduce means by removing imperfection, by carefully Mie scattering. It is spreading over